So folks, I don't want you to get the idea that you are limited in the sense that a particular access point has a particular range and how far it can be detected. And anything beyond that range, we've just got to start all over again and have a brand new network. That's not the case. We can have, in addition to a basic service set, in which the basic service area has a set of rules that applies to that area and is isolated and just all alone with that. We can also have what's known as an extended service set. So here's the key. To create an extended service set, what we can have is a couple or more of independent access points. And by independent, I mean they each have their own dedicated connection to the distribution system, to the switch. And if it's not the same switch, then at least to the same VLAN of switches. Okay, so they've got to be on the same side of the router, same VLAN, same set of switches working with each other. So they're autonomous in that sense so far. Any clients would participate in the same subnet since they're connected to the same VLAN. Now, when a client connects, remember they're going to connect based upon a service set identifier. There's a name that goes along with every network. That service set identifier is part of what identifies any particular basic service set, the configuration of an access point, in other words. But what if I configured two basic service sets with exactly the same name, but I located them at different channels? So there's a radio frequency. What if I just slid that certain portion of the radio frequency that I was using over a little bit so it was a non-overlapping channel? By doing that, a wireless client will be recognizing the access points that are available and the strengths that it has with those access points. As it moves farther away from an access point and detects that it's getting closer to another access point on a different channel with the same name, it will have the ability to roam, to basically say, I've already accessed this network, I'm just going to hop over here. And so it can present, hey, I've already logged on, see access point 2, I've already logged on to access point 1, I should be good to go here. What do you say? Access point says, sure, come on over. And so we can actually roam or migrate from one access point to another with no downtime, with no breaking connection, with the same IP address being applied to me as a client from whatever DHCP service we're using. Very powerful stuff. This configuration is known as an extended service set because you have one set of rules that apply to several basic service areas, right? The boundary, the physical boundary, the layer 1 boundary, essentially, of what an access point can reach. So ESSs are one common way that we're going to extend out our networks. And remember, that's based on the fact that we identify networks using the service set ID, the SSID. So the access point will announce the names, essentially, the SSIDs of the particular networks that it hosts. They'll have an identifier, and it'll even have and it'll present that identity with its MAC address. So it'll have so wireless uses MAC addresses just like Ethernet does to identify particular interfaces that we can use. And as we can see, I'm using what we were talking about before. I'm using an access point. The device, as it moves from one network to another, starts saying, hey, do you use this SSID? When an access point says, yes, I do, and let's say this is getting down to maybe 10% strength, and this is up to 20% strength, right? Then it's time to jump ship, right? I haven't lost my network, but it's time to jump to the identifier that will support what I need. So we're going to use that SSID to move from one network to another and create that connection. All right, so ESS based upon SSIDs of our APs that are connected to our DSs.